So I think it's about time to start my presentation. So hi, everyone. My name is Johnny Lin from Wiwynn. Today, my topic is going to share some OSF enhancement for debugging and usability with Intel Xeon platforms. But most of those sharing can also be applied with other architectures as well. So here's my agenda. First, Cloud Firmware introduction. Cloud Firmware, namely coreboot plus Linux boot, and also a status update, looking back at what we have achieved with Intel Sapphire Rapids with coreboot. And then I want to share some debugging enhancement, and then some usability enhancement. And then I want to talk about the advantages of Cloud Firmware, because most of the people here probably are more familiar with UEFI, but we think Cloud Firmware, coreboot plus Linux boot is a really good option here. And finally, call to action. Cloud Firmware introduction. There are many different BIOS firmware architecture for the OSF group. For example, OpenEDK2 and coreboot, Linux boot. We like to use the same name from BIDEMS, calling it Cloud Firmware. So Cloud Firmware is a type of OSF architecture, coreboot plus Linux boot. The Linux boot is the payload of coreboot. So from the figure below, the coreboot for Intel platform, the coreboot and Intel FSP handles the core silicon initialization and then jumps to a payload called Linux boot. The Linux boot is a standard Linux with a standard Linux kernel plus an inherent FS user space, so which can utilize the rich Linux environment. And finally, booting the target OS through KZAC. The target OS can be booted from local storage or over network. So the Cloud Firmware status update, we have been working with several partners, Meta and BIDEMS, Element, SysPro Consulting. The corporate support for the 4th generation Intel Xeon SP Sapphire Rapids has been publicly upstreamed. And the Intel 2-socket Ultra City CRB has also been upstreamed. Here's the link to the build steps for your reference. Also, there are several other Ecostream mainboards from the community, from the industry, that also have been upstreamed. So it suggests that it's pretty easy to port your board with coreboot plus Linux boot, Cloud Firmware. I believe they can provide good references to the industry. There are a 4-socket IBM board, a 2-socket BIDEMS board, which has been made into their production fleet, and a 2-socket Inventec board. The production branch with SMN ROS features is in a private repository, but I believe you can check with Intel. It can be obtained under Intel NDA. So here's a link to an Intel document on coreboot Ecostream integration. Now let me share some debugging enhancement. The Intel EWL enhanced morning log hub. The coreboot driver for Intel EWL hub processing driver has been upstreamed. It can detect and display a broad range of errors reported by Intel FSP. From the right figure, for example, the driver can parse from the Intel EWL hub and print there are EWL type 3 errors. Type 3 errors represents DDR memory error. So from the driver, we can show clearly that there are DDR training error and the major minor warning codes and the DIMM location, which socket, etc. And we can customize this driver to send an IPMI cell for the error. This driver can be extended for parsing more EWL errors like KTI errors, PCIe I/O errors, etc. So here's a coreboot change for your reference, and I believe you can customize it easily. And also please reference the EWL spec for the detailed EWL schema from Intel. Printing FSP MRC postcode to serial log. MRC memory training takes a lot of time. Without any serial output, it's hard to know what's really going on. So it's desirable to print postcode to indicate the progress. We customize our FSP to print the MRC postcode during MRC memory training to I/O COM port. So from the example on the right figure, the red squares are our customized postcodes during MRC training, and it's printing by FSP. So here we want to share that sometimes, actually a lot of times, if we want to reach a production-ready system firmware, customizing FSP could be necessary and useful for ODM, because sometimes we need to reuse the IP-sensitive modules from Intel FSP, although it's not open source, but lots of IP-sensitive source code are within the Intel FSP. And also we could create a customized hub data for coreboot to consume. And I believe you should be able to port your UEFI patches into FSP if it's really necessary to be done in FSP. Dynamically enable or disable Intel FSP Log. We can enable FSP Log for FSP debugging on the Linux boot shell. It's similar to the UEFI setup menu. But sometimes the machine is not able to boot to Linux boot shell in the first place. So for a situation like this, we can use a GPIO pin or an IPMI OEM command to enable FSP Log at an earlier stage. So from the example below, coreboot can read a GPIO pin to decide, hey, it's time to enable FSP Log at an earlier stage for FSP debugging. Easier debugging at OS runtime. It will be convenient if we can enable SMN log without doing a reboot, because a lot of time it's useful for SMN ROS live debugging while keeping the machine state. We have a coreboot SMN log control VPD that can let us turn on or off SMN log, but that requires a reboot to take effect. So we can read a GPIO input pin at runtime from the right figure as an example. The coreboot SMI handler can read a GPIO pin for each log print dynamically without doing a reboot. So this way, we can enable SMI log dynamically, turn it on or off under OS runtime. This approach can be applied to all coreboot stages, but I think only SMI handler is needed. Dynamically override Linux payload's kernel command line. So the Linux payload kernel command line is statically configured at build time. There are many different Linux kernel command line, of course. So we made a coreboot driver that let us can override the Linux kernel command line parameters dynamically through VPD variables. For example, from the example below, we can override Linux command line parameter log level to a different value through a VPD variable, kernel log level. So we can change this VPD value dynamically, maybe through Linux shell or other method. So when we don't need to see the Linux kernel log, we can change the kernel log level from 7 to log level 0. That can gain 10 seconds faster booting time. So this driver can be extended for other kernel command line parameters for other usages. And also we have the change for your reference. Now let me share some usability enhancement. Optionally skip MRC training after an in-band image update. We all know that MRC training takes a lot of time. And after an image update, we need to do MRC training. The idea is pretty simple. We can skip MRC training by backing up and restoring MRC cache data after an image update. There's a coreboot flash ROM defined an MRC cache region on BIOS flash that stores the MRC training data. And we can use flash ROM during our in-band update that we can back up the MRC cache data first then update the BIOS image, and restore the MRC cache data back to flash. So this way, FSP will skip MRC training after reboot. The applicable scenario when there's no MRC or and flash layout change in the new image. And the benefits obviously can save lots of time for engineers and data centers operations. Here's a Linux script for the flash ROM in-band update example for Intel Ecostream. From the red square, flash ROM can read the MRC training data first and flash the BIOS image and write back the MRC cache data. Improved uroot boot commands with grub support. The Linux boot initRandFS user space we use is called uroot. It's written, it's busy like initRandFS user space written in Golang. The uroot implements its own grub parser without relying on any external grub binary. It's better and more flexible to have your own grub parser within your system firmware, but it's not yet a full-fledged implementation. So we add 2 grub support to uroot boot command. One is we add grub default boot option support. You can parse the grub config text file, and you can configure the default boot options. So the default boot option will be displayed as the first one. And here's the change for your reference. We also add multi-boot 2 and module 2 grub keyword support for our tboot. So from the right figure, the default boot option is displayed as the first option, and option 4 and 5 are our tboot boot option that can be parsed and launched from the boot menu. And finally, we make system boot as a uroot init daemon that switch to use the better maintained boot and pixie boot commands. Here's a change for your reference. So I want to share the advantage of Cloud Firmware. So I think a lot of reason that Meta and other companies started the OSF project is there are some pain points we want to solve. With open source OSF project, we can have a more efficient working model. With a proprietary working model, for example, Intel releases its reference code to IBV, independent BIOS vendor, and BIOS vendor integrates and releases the code to ODMs downstream. There are several drawbacks from this working model, and it's not efficient. 1, slower Intel BKC integration. 2, there are multiple code bases makes it more difficult for issue clarification. I think we all have the experience that we need to spend quite a lot of time to clarify which code base introduce a certain issue, maybe from Intel, from IBV, or from ODM. That takes a lot of time. And 4, we cannot share works or bug fixes easily with each other. With open source working model, those problems can be avoided. With one common code base, Intel and all other parties, we can all develop and debug together, and also with the help from open source community. And 2, faster time to market, because with faster Intel reference code BKC integration and faster turnaround time for bug fixes. And 3, faster patching and image release. Any party is able to apply patches and build an image. So this is really a lot more efficient. So let me summarize the advantage of Cloud Firmware. We think there are 5 main advantages. 1, talent. Because we use Linux boot, there are many Linux engineers from CSP and from the industry that we can leverage from. Also, I think this also applies to coreboot, because coreboot is pretty similar from Linux kernel. And then security. Just recently, CISA published an article stating that UEFI is a critical attack surface. And I think most of the people agree that an active open source community can produce better security and faster patching. Both Linux kernel and coreboot have very active open source community for code review and bug fixes. So we can achieve better security from the benefit of active open source community. And also with coreboot's much smaller attack surface, I think that's what coreboot are known for, is condensed code base, simple to develop. And then reliability. Coreboot and Linux kernel are statically linked, so the execution process is very deterministic comparing to EDK2 dynamic module loading. So the booting process is very reliable. And also, Linux kernel network stack also shows much better reliability comparing to EDK2 network stack. Then simplicity. With coreboot's much simpler code for development, I believe some people had experienced that it's more difficult to find UEFI engineers comparing to maybe Linux kernel engineers from the industry, and people can pick up coreboot probably much faster than EDK2. And then finally, efficiency. A more efficient working model with direct cross-company collaboration. Maybe not every company is willing to share their code with one another, but I think at least for Wiwynn and our partner, we are willing to share our code because it makes our project more efficient and it can keep it on schedule and fix the bugs very fast. And also with coreboot, much faster build time. It's about 1 minute build time. So call to action. A more efficient working model plus easy to develop equals to faster time to market and turnaround time. Fast time to market and turnaround time are in everyone's business interest. Whether you're a CPU vendor, whether you're a BIOS vendor or ODM system integrator, those are in our business interest. To make the project successful, I believe this firmware stack is beneficial for everyone. So we encourage more enterprises and cloud service providers to evaluate and join this effort for a more secure, reliable, and efficient system firmware architecture. Here's a link to coreboot and uroot for your references. Thank you. So is there any question?
Okay.
Okay.
Thanks, Johnny. Nice presentation. Yeah.
Thank you.
Thank you.